Welcome to exercise 4. Now this seems like an easier way to measure friction, and it is as long as you have a calculator that does tangent. So if you've looked through all the theory, and in the beginning your teacher should have derived this for you, finding the coefficient of friction using an angled ramp is actually quite simple. All you have to do is raise the angle of the ramp until the block moves. Oop, it's going to move eventually. There it goes. See it? It moved. So the trick is to measure it just to the time it moves. Now that, of course, was for the static case. The kinetic case, what you do is you increase the angle and push it each time to see if it moves at a constant speed. If it moves at a constant speed, that means it's not being accelerated. So I've got a jack underneath here, and to figure the tangent is opposite over adjacent. So that means the horizontal distance, you know what I'm going to do is I'm going to put a brick here, because just so that this thing doesn't move each time. At the end of I'm going to put a brick at the end of the plank so it doesn't keep moving when I move the plank up. So what we're going to do now is I'm going to push it, and I'm going to see if at this angle it moves at a constant speed. Nope. Nope. So obviously the angle is too low. So I'm going to move the angle up and try it again. Nope. Continue to move a little bit each time. Well, it goes a little further that time, but still no. Nope. So it's quite higher. Not yet. Now, by the way, the reason why this works is the frictional force in this case is going to be counteracted by the gravitational force. There's a component of gravity along the ramp that we discussed in the last couple of labs. In fact, the very last lab, Newton's Law lab, the g sine of theta and mg sine of theta is the force pulling down the ramp. The acceleration is g sine of theta. So using that g sine of theta, doing trigonometry, you can figure out the coefficient of friction is tangent of theta. That has to do with, what you do is just combine the normal equations with equations down the ramp. So let's try this case. No. Almost, though. I can see it's moving. All right, well, let's see. It stopped still. I don't think it's still at its spot. So we're going to do 3 trials of this, which means I find, okay, I think it has to go a little bit higher than that. See, it stops still? I'm picky about it. I'm picky. No, it still comes to a stop. Now, unfortunately, we also have to take into account that it's still stopping, that throughout the whole plank, the coefficient of friction isn't constantly uniform. That's one of the biggest errors in this experiment, is the plank and the block are not uniformly smooth. I think we got it. So you can see my meter stick. What I'm going to do is put the meter stick at the edge and at the bottom edge of the plank, and then measure the horizontal distance. And what I'm going to do, it's kind of hard to do that, but you see the edge, the end of the plank there? I'm going to put a ruler and stick it right on the meter stick where I think it's at the very end. All right, so this is 70, 77. It looks like it's right at 78. So I would say 78 centimeters is the horizontal distance. So that's the adjacent side. And this is going to be for trial number 1, 78 centimeters. Now, of course, along with that, you have to measure the height. So let's measure the height. Now, just to let you know, this does not start off exactly at, this ruler doesn't start exactly at 1 centimeter. It's about a few millimeters off. In fact, what I can do is I can correct for that by measuring it on here. Let's see, so the amount is 1, 2, 3 millimeters. So I still have to put it on the ground, but we're going to have to subtract 3 millimeters off our result. So in centimeters, the height is, and again, we have to measure to the bottom of the plank. So let me move this over so you can see the bottom of the plank. So 23.5 centimeters. Now remember, it has an extra 0.3, so that would mean 23.5 minus 0.3, so 23.2 would be the height. Okay, 23.2 would be the height. And now let's go ahead and do the next trial.